Now I'm going to show you how to program your part by GibbsCam. This is the 3D model of your part. You can start from 2D or 3D. So I will show you how to start with 3D. You just need to drag into the GibbsCam and select which type of machine you want to use. So I'm going to use a 4-axis turn mill in this case, and choose then OK. Okay, and this will be the part that we're going to program now. The first thing that we need to have to do is to specify the materials. Let's say I'll put maybe -9 in front, 1 mm material in front, and extra of 40 maybe, and my clears 45. This Z clear 5, and everything set up. Let's go to home view. This will be the material. Okay, this will be the material, and I can also load the machines with the material. So here we can choose machines. Of course, machine simulation is optional in GibbsCam. I'm going to choose this machine. This is my demo machines for this turn mill. I'm going to set it up maybe 150 out of the chart, and this will be my materials for the cutting. Now I'm going to start the machine. This is the tool magazine of the machine, and this is the area that you put your operations, and this is all your cutting process. Now I'm going to create a face mill now. Let's home. So we have a 1 mm material in front. So to create a tool, just double click this one. From here we can choose, for example, I'm going to choose 80-degree insert, and maybe a 0.2 radius, and this is holder. And I also can set up this tool inside the machines. So if I load the machine simulator, you can see the tools here. There you are, the tool. Okay. So beside turning tool, you can also create milling tool, drilling tab. So I'm going to delete this. So this is how we create a cutter in GibbsCam. And next, I'm going to create a facing operations. So I just drag from here, and over here we can switch from turning operations or milling operations. So I'm going to switch back to turning operations and drag one and drag the tool to put into these operations. Now I want to do a front face, so I can choose the front face, and you can set, do you want to put some offset or not. Okay, in this case I will just do a finish facing, just cut one time. And next thing what I need is to select the line, the profile. So in GibbsCam is very unique. We have a profiler for you. You just click this profiler, and automatically you will have the line for, or the profile that you need to select. So in other CAD system, you might need to draw this profile out. So now let's say I'm going to do a facing here, and over here I can do some adjustment. I say cut from here, and I want to cut until 0, and just click do it. Immediately I have this result, and I can always go to the machines to look at the result. To see how your cutter is actually cut as I will put it to transparent here. So this is spacing for the part. Now let's say after this facing operations, the cutter that you defined and the settings that you set, the feed rate, the cutting speed that you set, everything is good. So in that case, you can always save these operations for future use into your company library, okay, for future use. How to do that? You just go to process and save, and just choose a location that you want to save. So you might have your own library for your company. So I will say my facing, just like that. So next time if you want to do some facing by using this tool, you just load it out. No need to do any setting at all. So times go by, you will have all the knowledge inside your company. Okay, save inside your company as a template. Now, so after facing operations, maybe next operations that I will do, I'll start from the inside of the part. Maybe I'll start with a drill, a sander drill. So in this case, of course, I can define the drill manually, define the process manually. Again, if your company already have a template for the sander drill, for example, for diameter 10, you can always just load it and execute. So I'm going to do that now. Just go to process, maybe go to your company library. Okay, you just choose which. Okay, I will select this one, a sander drill diameter 10. So what I need, just load it out, and all the setting is done. The cutter is done, setting is done. So what you need to do now, just click do it, and you have a sander drill. So I'll show you the result. It's too fast, I can slow it down. Start from the facing operations, and then sander drill operations. So this drill is with packing, all set by the template. So this is how to use template in GibbsCam. Template allow you to save the knowledge into your company. Now, let's assume I'm your company new engineer and I'm totally fresh, but your company already have a template library saved by your experienced users. And how I'm going to do the program now? First, of course, I need to identify which area I want to machine. For example, now I want to machine the inside by grooving, for example. So what I need to do is just go to your company templates, company library, and find which one you want to do. Let's say, okay, I found a template for the grooving. So immediately the cutters is here. This is the cutters that you have inside the company and the settings that is set by your experienced users. Okay. So next, what I need to do is just to select the contour, which contour that I want to machine. So I will select here, and maybe I will end over here and at this line, and let's here I will drag out a bit, extend a bit, and here I also move this to this point. And since I will check my cutters, the width is 2.5, so I would offset maybe minus 2.6, and then just click do it, and there you are. The grooving for the inside is done. How about the bottom side? So again, I can go and try to find some template from your library. Okay, so and I find this, just load it, and we have another cutter that reference at this point for this bottom groove. And what I need again is to select so I will start from here to these locations. Okay, so I can also say I want to start here and extend the line a bit out, and from here extend a bit, and just say do it, and I have another grooving operations. So as you can see, I just create two processes with a template without doing any changing on the cutters or the operation settings. Next, I'm going to continue to program this part with the template. So after we have a rough, next we need to do some finish operation to clean the steps. And again, I go and find inside library, do I have something like this? So yes, I have. And then if the cutter is here, it will not create another one, it will use the same one. So this is the setting for the finishing. So I will start from maybe this one. So I will apply these directions and start with this curve to somewhere here. Okay, this one extend up. We will do a finishing over here. Maybe make it shorter. This will be the finishing with the tangent here. I can control tangents if I want. Next, again, I will apply the finishing for the other side. Again, I will load it from the library. How about the lower one? Yes, I have one here. Let's go. And now I'm going to machine these directions and start this, extend out a bit and put location somewhere over here and do it. If I want, I can do a simulations, and I can use this one. I can ask the simulator to stop at operation. Maybe I'm going to stop at operations number 5. Use operation stop so that I can fast forward. Okay, and stop just before the finishing of the groove. So here's the step. So now is the finishing, that cleaning the groove. So for these operations, maybe I will reduce the distance a bit over here, and it's done for the finishing of the internal. Now next, what I'm going to do is I'm going to make a ball, a turning ball over here. We already drilled this with diameter 10, but this hole is around 10.2. So I'm going to do a ball, and again go library. Do I have any ball? Yes, there's balling with the balling tool like this. And next, what I need to do is to select geometry, the curve, and I will start from here and end here, and just click do it, and I have the balling operations here to cut the internal one. Okay, this is cut. Again, I will ask the system to stop at 7. Let's fast forward and let's check. This is operation 7, the ball. Yeah. After complete the internal operations, now I'm going to work with the external operations of the setup one. And so I might need to start with the roughing or OD roughing. Again, go to your company template, standard template from the company. I will choose, for example, OD rough, and select the contour. So this one I will ask it to start it way out and here, and this one I will say move it just 3 mm back, extend, and then do it. And now I have the OD roughing process, and you can see here this area is a groove, and the cutter is not going in because at the process I say don't go X minus, because it will touch the back side of the insert, and that is not a good thing. So after we have the roughing, of course, next is to go for the finishing. So I will choose a How about a, or first we wrap the groove first. We work on the groove first. Let's see here. This groove, some extra material here. So I'll go and say, do I have anything that can work with groove at the library? How about this? Okay, groove. And this is the cutter we are going to use for this. And next is to select contour, and I will say my starting contour will be here and the ending will be here, and I just extend out of the part, and the system will automatically find where's the remaining material and cut it. And so I forgot to on the remaining materials. You can see a lot of air cuts over here. So now I go back and change this and just redo. And now you only cut all the materials. And after we cut the groove, next, okay, it's time to apply the finishing for the OD. Again, I'll go to the library and look for the finishings. Do I have any finishing here? And OD finish, okay. I will select this and then select my contour and this directions and move up this and move this and extend this back to 2 mm and do it. Now you can see the finishing is a bit funny. This might because the settings at your operations is different. Okay, so after you load from the template, if you want to do some other changes, still possible. The template is not a fixed thing. You can change it, and this is what you want. Shorten it. There you are, the finishing. So after finishing process, next I will do something on the thread over here. For the thread, okay, so from the drawing I can see that it's M35, something like that. So I go to the library to check for thread cutting, and do we have any M35 thread cutting? Yeah, this one is the thread, and this is the thread cutters, and the setting is done for the M35. You just click do it, and that's program for the thread. So after we have the thread, next step, I think this is the last one, is the parting. I'm going to cut off this part now. Again, you can get a part off cutter from your library, cut off, and just choose the line that you want to cut off. And I will move this point somewhere here and this outside and do it. And this is my part off program. So after we have done, then next we can go for simulations. And if you want, you can always section the part to look at the result. So I'm going to fast forward to cut everything at ID, and then next is the OD. This is trading, and part off, with with steps. This one you can set, and the first setup is done. And one thing about this thread, if you look closely, the thread is actually is helix, is not in circle. It is two. The thread is real, true thread. Now, after finishing the setup one, and next step you might need to optimize the cycle time for your part. So we have a so-called operation manager here to let you look at the cutting data and optimize the cycle times. The cycle time is here. For example, let's say operation 1 it takes 7 seconds, and you might need to reduce this. So, for example, I'm going to change this to maybe instead of feet 0.2, maybe 0.4, and just redo these operations, and then just calculate again. And you can see now down to 5 seconds. So this is how you can optimize cycle time of each operations. And the data shown here, you can actually customize it. If you don't want to see some of the data, you can remove it or add. So after the cycle time is fully optimized by the operation managers, next is to post out the programs. Before I post out the program, I will create the setup report first. The setup report is actually automatic in GibbsCam, so you can have some part report setup and just click OK, and the system will do the rest for you. And this is the result. This is the result. Let me make it smaller here. Of course, it is in Excel, so you need to install Excel in order for this auto report to work. This is the part informations. Beside this report, I'm going to show you another one. Automatic report. How about the tool report? You might need a summary of all the tools that you are using. And here you are, the tool report. So we have 2 pages. One is for milling, one is turning, and all the information regarding the turning holder, turning insert, everything is here. At the last one, you can have operation reports. And this operation report is very unique. It shows you the operations parameters, show you from start condition, end condition of each operations, start and end conditions of each operations. And of course, if you want, you can always customize use a custom report if you want. Next, I'm going to show you how to convert this kind of lines, the motion, into G code so that your machine can run. That is called post-processing. Just click on this post, and then you go to choose the post processor of your machines. So each machine you might have different post processor. So let's maybe I'll choose some machines here. If your machine is spatial or you need to customize, we can customize the pose according to your machines. And after you select the pose for your machine, next you of course to specify where do you want to save your NC file. So I'm going to save inside this folder here, and then you just click post process, and this is your NC for the first setup. And what you need to do is to send this program to the machines, and machine can run. Okay, and for sometime after you send the program to the machines and your customer call and want you to furthermore modify the program to reduce cycle times. If you don't have any CADCAM to do this, you need to do it on the machines, and it takes a long time to do it. So if you have a CADCAM, what you need is just to select the operations, apply some setting change, redo the operations, and post again the G code without needing to edit the G code at all. And this is fast. So after complete of setup 1, after the simulations, and to continue with setup 2, you might need this stop, okay, for the stop of the second setup. Okay, so to do that in GibbsCam, and this is unique in GibbsCam, so you just click on the create facet boarding in GibbsCam, and there you are, the stop for the second setup. Now we are at the setup 2, and as you can see here I'm using actually the stock that have already cut by setup 1 in setup 2. Use this one as the stock. Okay. Let's look at the part again. So now, how about I will start with the turning. Go back to home for turning. So if you look at the stock here, we still have something to cut for the turning. So again, I will apply a phasing operation for this, and on the profiler, and again I will go to my library to see anything that I can use or not. For example, hit this one, and then I'll choose line, start from this curve here, and here extend it out and down here, and then do it to create the operations. So you do a simulations. This is what happened. Let's see. Go for transparent mode. Phasing operations. Okay. So after the phasing operations, after the phasing, it will be the drill. After phasing, next we'll work on this hole. So we will change the plane to XY so that we can drag the profile profiler to profile the 3D part to get the profile that we want. In this case, we have a 3 hole that is in different angle. So, and this is M1.6. So again, I will apply go to the library, search for M1.6, and all the settings done. The drill tool, start from drill, then go tab. So in one operation, I'm actually using 2 tools now, and here I need to change to XY plane and no copy because the angle is different, so we cannot copy. Make 0. So next step is to just select the hole that you want to cut. Use Ctrl key to select the 3 hole and just click do it. And now you can see it is the C-axis moving. C-axis moving, not the Y. Why? Because here we have the option to set. Okay, if I set this one, that means I want C to move. If I set this one, X, Y, Z will move. So in this case, of course, we try to use C if possible, because Y you might have some limits. And here comes the tab. Okay, after the drilling, next step is to for drilling. So for this circle here, I'm going to apply some profiling, some milling. Again, I will apply from a template, from your company template. And about do I have a 2 mm mill here? Okay, so I'm going to perform a roughing operation and finishing operations in one. Next is to choose the profile that you want to machine. Let's say this is the profile, and the starting is this, and the ending is this. And then you have to check again. Make sure it's select a correct plane, and I'm going to copy this 3 times 70 degree, and this also is XY plane 3 times 70. Then do it, and you can see is copied at the wrong directions, so I can always go and edit it. So actually is -72. The initial setting is correct. -72 and redo. So if you have some features that is at a constant angle, and you can just make one and copy it by angle. And the milling for this location is finished. Let's go and see. start at process number 4. Okay, let's fast forward. And next is the milling process. So I will slow it down to show you how it is done. And the milling again, I'm actually using the C, X, C, and Z to mill. Because for this, if you use X, Y, Z to mill this profile, you might face some machine limit problems. Normally, the Y-axis limit is very small. So for if you have big part, it is good to machine by the C. Now is the finishing process. And it's done. Next, I'm going to work with this small profile here, and I'm going to show you how I program by using the XYZ. So again, to load the template, let's look at your company library, and let's use the MU1, and then select contour, extend out to this area, extend out, and do it. Forgot to change the plane. Do it. And you can see here the setting here, I'm using positioning. That means I'm actually using X, Y, Z for this program. Again, for the second profile, extend the line up to here, extend the line and do it. This will be the second. And let's look at the simulation now. And I'm going to change it to stop at process number 8. Okay. And let's go fast forward first. And this is the first profile. For a second, I will slow it down, and you can see the tool currently is moving by X, Y, and Z. The C is not moving. So in GibbsCam, you have a very flexible option for you to change to any axis that you want. And this is the last operation for the setup tube.